There was a time when mathematicians refused to believe in numbers that went below nothing. They didn't just dislike them, they rejected them. Too many of the greatest minds in history. These numbers felt unnatural, dangerous, even meaningless. How? Could something be less than nothing? You could have one apple, you could have no apples. But how could you have minus apples? This single question haunted mathematics for centuries, and for a long time, the answer was simple. You couldn't. In the ancient world, numbers were not abstract ideas. They were tied tightly to reality. Numbers counted sheep, measured land, tracked time, and recorded wealth. Numbers described what existed. If something did not exist, it was not counted. So when early mathematicians encountered the idea of a number smaller than zero, they didn't see a new concept. They saw a contradiction. To them, negative numbers felt like ghosts. They had names, but no bodies. They could be written, but not understood. In ancient Greece, numbers were deeply connected to geometry. Lengths could be drawn. Areas could be shaded. Shapes could be seen, but you could not draw a line shorter than nothing. So mathematicians quietly avoided the idea. If a calculation led to something below zero, it was treated as impossible, meaningless, or simply ignored. The result was dismissed, not explored. Elsewhere, the reaction was different. In ancient China, merchants and scholars dealt with debts and profits every day. They used counting rods laid out on tables. Red rods represented gains. Black rods represented losses. Without naming them explicitly, they were already using negative numbers to them. Owing money was just as real as owning money. But even here, the idea remained practical, not philosophical. Negative numbers were tools, not concepts worthy of admiration. In India, mathematicians went further. They began to describe numbers below zero using ideas of fortune and debt. Gains were positive, losses were negative. This was a quiet revolution. For the first time, numbers were allowed to represent absence combined with direction. But even then, acceptance was slow. Many mathematicians used negative numbers in calculations. While refusing to acknowledge them as legitimate results, they were tolerated, not trusted. In medieval Europe, the resistance grew stronger. Mathematics was expected to reflect reality as clearly as possible, and negative numbers seemed to violate common sense. If a problem resulted in a negative answer, it was often labeled false or absurd. Some mathematicians called them fictitious numbers. Others called them meaningless. A few simply refused to write them at all. The confusion wasn't stubbornness, it was philosophy. Numbers were believed to describe quantities that existed in the world. Negative numbers described something that could not be seen, held, or measured directly. They required a new way of thinking. Not numbers as objects, but numbers as relationships. Slowly, painfully, that shift began. People started to realize that numbers did not have to describe physical objects alone. They could describe states, temperature below, freezing movement in opposite directions, loss as distinct from gain. Suddenly, negative numbers had a home. They were no longer less than nothing. They were movement in the other direction. Once this mental barrier fell, mathematics changed forever. Equations became more powerful. Symmetry emerged. Balance took on new meaning. Negative numbers didn't break mathematics. They completed it. And yet, the fear never fully disappeared. Even today, students hesitate when they see a minus sign. Something deep inside still whispers that it shouldn't be there. That hesitation is not weakness. It is history. It is the echo of centuries of resistance, confusion, and disbelief. Negative numbers remind us of something important. Mathematics does not only grow by discovering new truths. Sometimes it grows by accepting uncomfortable ideas that challenge intuition, ideas that force us to rethink meaning itself. The numbers people hated were not wrong. They were early, and once accepted, they became essential. If you enjoyed this story, stay with MathsWhisperer, because mathematics is not just about numbers. It's about how humans learn to think beyond what they could see. And some of the most powerful ideas began as the most hated ones.